Section 4.3, which is the greatest common divisor and least common multiple. So in 4.2 online, you guys actually learned about common multiples and or about multiples and divisors, right? In section 2. So in section 3, we're going to do the greatest common divisor and the least common multiple. And the first thing we're going to do is we're going to encounter some of that language. A greatest common divisor, that's called a GCD, or sometimes referred to as a greatest common factor, GCF, is just the biggest number that divides everything in a set of numbers. Okay? And I've used this word already several times, this word relatively prime. Two numbers are relatively prime if their greatest common divisor is 1, i.e. they don't have anything in common except 1. Okay, so that's like the numbers 3 and 5 just a moment ago when we were looking at this problem on the board, right, Beth? Mm-hmm. Yeah. And it doesn't have to be numbers that are actually prime. They just have to be prime to one another. So we could look at the numbers 8 and 15. 8 and 15 don't have any factors in common. Neither one are prime, right? But they are relatively prime to one another. It's a comparison of the two numbers to each other instead of comparing them to what prime and composite actually means separate from that. Okay? So there's several different methods for finding greatest common divisors. There's an intersection of sets method. And what this method does is it lists all the divisors of each value, and you find the biggest one in the list. So we're going to give that one a go first. We know that 12 and 15 have something in common. So what we're going to do is we're going to show this. I know that you probably were able to do this without making a list, but we're going to do it anyway so you can see how the method works, okay? All right, so I want to list all the factors of 12, both prime factors and not prime factors. We're going to start with the number 1, because 1 divides 12, agreed? Okay, what's the next number that divides 12? 2. And then 3. 4. 6. And 12. Got to end with the actual value itself. Okay? And we're going to do 15. First number that divides 15. 1. And then 15. All right. And then you look at the two lists and you find the one that they have in common that's the biggest. And they'll always have something in common. What will they always at least have in common? 1. So there's always something. Which one the biggest something? The biggest something in these two lists is 3. When I tell you to collect them, you get it. Okay. Any other papers? Did everybody pass this over? Reuse? Trouble? Don't wait. Okay. This is intersection of sets. All right, so I should have written down the answer. Let me do that. So the greatest common divisor, or you could say GCD or GCF, is 3. Okay. Prime factorization method. Prime factorization method, well, let me just say the last one, the intersection of sets method, works pretty nice when the numbers are solved. 12 and 15, I don't mind writing out all the factors for that. I'm not sure we'll want to write out all the factors for 400. Are you guys with me? This would be a longer list. It would take me a bit of time. I'm not sure that's an effective way to do it, or at least efficient. So we're going to look at the prime factorization method instead. So what we're going to do is, and I'm going to show you, yeah, I'll do it this way. The next one's the one I'll show you next. But we're going to actually do that same sort of division that goes down that you saw in the video from last time. And I'm going to go in order, not that you have to necessarily go in order, but it just kind of keeps things organized. So what's the smallest number besides 1? But we're looking at primes now anyway. The smallest prime number that divides 400? 2. And what do I get? 200. Smallest number? 2. And I get? Smallest number? And I get? Smallest number? And I get? Smallest number? And I get, see, I like this method. Okay, it's pretty clean. Let's do 360, smallest number. And I get smallest number. And I get smallest number. And I get, good. Now you have to pause for a minute to really think. What's the smallest number? 3 is actually the smallest. Okay, we definitely would not want, if we did 5, it'd be okay. Let me just say that. We wouldn't want to do 9 though. Why would 9 not be a good one to choose here? It's not prime. So we want to make sure we choose something prime. So either do a 3 or a 5 here. It's really not a big deal if you put 5. But if I do 3, because it's the smallest, what do I get? 15. Smallest number? 3. So Haley, do you see your 2 3s here? Makes 9. And what do I have left? 5. Okay. So this is the first thing. We construct a prime factorization for each number. We did part 1 for step 1. Step 2, choose all prime factors that are common to each factorization. Okay, so if I choose a 2 on the left, I choose a 2 on the right. Only if there's one in both lists. What else? Another 2. And then another 2. And then a 5. And that's it. Right? Everything else that's not circled does not match anything in the other list that's not circled. So my GCD will be the numbers that I circled, listed only once. I circled 3 2s and a 5. And is there a more simplified way to write 2 times 2 times 2 times 5? We can write it as 40. How else could you write it if you wanted to leave it in primes? 2 to the 3rd times 5 if you want to leave it in primes.
You know what?
I've got both of them written down here. So unless there's an indication of your book on which one they prefer, either one should be fine. How's that? Okay. Okay. Division by primes. I really like this method because I'm going to show you how cool this is. This will be our last one. This method, I'm going to write the 410 and then 360. Oh. Like this. Okay? Right there beside each other in their own big old division bar. You'll do okay, Lauren. What I have to do is I have to look at both numbers at the same time and ask myself what goes into both of them. 2. Smallest thing, okay? 2. Because we're still doing common prime factors. See, it says divide each number by common prime factor. Okay, so what's 410 divided by 2? 205. What's 360 divided by 2?
180.
Awesome. Okay, I can't divide by 2 again. Why not? Yeah, because 205 is odd. So what could I divide by? 5. I can't divide by 3 either. Why? 205 isn't divided by 3, but 5 will work, yeah? All right, so what's 205 divided by 5?
41.
41. And what is 180 divided by 5?
36.
Okay. 41 is done is prime, right? So unless 41 divides 36, and you know it doesn't, you're done, okay? You're done at this point when the numbers on the bottom have nothing else in common. Once they have nothing else in common, you are stopped. And the cool thing is, your answer's right here. There's no looking for things in common because you looked for things in common as you worked the problem. So it's kind of friendly. All the answer is just on the left-hand side. Your book is the first place I've seen do this, and I think it's fabulous because my answer is so nicely compacted at the end, and I don't have to go searching for things. I don't have to look for things in common. They're already in there for me.